Hello and welcome to Education at SSBJ Online Video Tutorials. In this video tutorial, we are going to take up a very important question. You can expect this in your examination. And the question is, derive third equation of motion by graphical method. We know that there are three equations of uniformly accelerated motion. And what is uniformly accelerated motion? If a body changes its velocity in equal amount, then it is uniformly accelerated motion. And what are those three equations? They are V is equal to U plus AT, S equals UT plus half AT square. And third equation is V square minus U square is equal to 2AS. In the previous videos, we have already seen how to prove V is equal to U plus AT by using a graphical method. And we have also proved S equals UT plus half AT square with the help of graph. Now in this video tutorial, we are going to prove V square minus U square is equal to 2AS by using graph. Now this is very important question if you think of your examination, maybe ask for 3 or 4 marks. Now we shall start. We know that if you plot a graph, velocity against time, right? A velocity will be on y-axis and time will be in x-axis, right? This is x-axis and this is y-axis, and I have taken some random numbers here. They represent velocity and that is in meter per second. And on x-axis, 1, 2, 3, 4, 5 seconds they are the time, right? And suppose if you can consider an example, it is just an example. If you take here for the first second, if a car is moving in 2 meter per second, so we have to take this on velocity axis somewhere here. For the first second, our mark will go somewhere here to be precise, right? In the same way, again if it moves for the second, and if the velocity remains same, that is 2 meter per second. Look at this. Here also it was 2 meter per second. Now also it is 2 meter per second. So the second point will come again on the line of 2 meter per second. And then third second, it is again on the line of 2 meter per second. And so on 4 second and 5 seconds. So if you join this line, you get a line which is parallel to x-axis, right? Parallel to x-axis. Now can you tell me what is the acceleration here? Acceleration is due to change in velocity, right? Acceleration is due to change in velocity. But is there any change in velocity? There is no change in velocity. It's a constant velocity, and that is 2 meter per second for every second. So since velocity is not changing, therefore, what is the acceleration? There is no acceleration at all. Acceleration is 0. Suppose if you draw a line here down till x-axis and then from here again till x-axis, you get a rectangle, right? We'll call that rectangle as ABCD. Now what does the area of this rectangle represent? We have already studied if a graph is velocity versus time, what does the area below the graph represents? If you can put that in the equation, area below the graph can be equal to area of the rectangle ABCD, that is length into breadth, right? Now what is actually AB? AB is nothing but velocity, right? That is initial velocity. We can consider this as velocity. So in place of AB, I can write it as a velocity. And what is AD? Area is AB into AD, right? And here BC and AD length is same, right? So what is AD mean? AD is nothing but time, right? So in place of AD, I can write time. So actually what we are doing is area of rectangle ABCD, if you calculate, it comes like velocity into time. And what is velocity? Velocity is equal to displacement divided by time. If you do a cross multiplication here, right, you will get velocity into time. You look at this, velocity into time is equal to displacement. Here when we are talking about straight line motion, a displacement and distance will be same, and therefore velocity into time is equal to distance. So what does this velocity into time is equal to? Distance, right? So what we have understood now, area below a velocity time graph will represent a distance covered by the body. Please remember, the graph should be velocity versus time, and that will give you distance covered by the body, area below the graph, right? Now let us take another example. We shall take out this example, and on the same graph we shall try to draw another example of this time you will take velocity is changing now here. Per second velocity is 2 meter per second. Second velocity is 3 meter per second. Yes, this is correct because it's 3 meter per second here for the second. Third second velocity is 4 meter per second, and fourth second 5 meter per second. Fifth second 6 meter per second, right? So if you draw the graph here, you get a graph of straight line like this. Now look at this, its initial velocity is 2 meter per second and final velocity is 6 meter per second. And what we have understood, area below this graph will be equal to the distance traveled, right? Now how can we find the area below the graph? If you join these lines, you get first triangle, rectangle triangle, and then still there is an area, it's a rectangle. So all together this is the geometrical shape, right? So if you give name here A, B, C, triangle ABC, and then rectangle E, C, B, F, right? Now suppose if you want to find out the area of complete shape, then that is equal to area of triangle plus area of rectangle, right? So here I have written area of triangle, this triangle, and area of rectangle here, and that will give you the distance covered. And if you add this, suppose, what is that shape we are getting? That is the shape, the entire shape from here to here, here, and then this complete shape is actually a area of trapezium, right? Now what is the area of trapezium? We will call this trapezium as ECAF. So this is our trapezium, ECAF. You can see trapezium has two sides which are parallel, and this is what is called height. Now let me highlight these two sides. First is CE, right? And then second is AF. These are the sides which are parallel to each other. So here is very important understanding we should have to prove this, right? And that is, what does EC or CE represent? Now if you look at the y-axis, EC represents 2 meter per second. That means EC is from here to here is the velocity. And which velocity? It is initial velocity. And how do you represent initial velocity? You know, it is represented by small u. You have already studied it. So remember, CE is, the length of CE is nothing but initial velocity. In the same way, the length of FA from here to here, what does this represent? A meets with 6 meter per second. It is not 6 meter per second at this point. It is from here to here. That means the entire length represents 6 meter per second, and 6 meter per second is the final velocity. And how do you represent final velocity? That is small v. So this is very important thing. So once again, CE represents initial velocity and AF represents final velocity, right? Now we'll go for the formula to find out area of trapezium. We know that this is a height of the trapezium, and height from here to here is nothing but time, right? So we have two parallel sides and the height, and therefore area of the trapezium is equal to sum of the two parallel sides, this one and this one, sum of the two parallel sides into height, that is EF divided by 2. Now sum of the two parallel sides, that is CE plus FA, right? CE plus FA into height. Height is, you can straightway take it as T, right? Or EF divided by 2. Now we have understood that CE is nothing but U and FA is nothing but V. So you substitute that U, CE is U, FA is V, and what about EF? EF is T. So this entire expression becomes U plus V into T by 2, right? And then we already know that acceleration is V minus U by T. Remember this. This is a very important formula which we are using here. What is acceleration? Change in velocity divided by time. And change in velocity is V minus U divided by T, right? So what we are doing is, we are going to find what is T then. Cross multiply, you will get T is equal to, so T takes a place of A, so T is equal to V minus U divided by A will go down. After that, this value of T we are going to place here. So what happens? Our equation becomes U plus V divided by 2 was already there. So we are replacing T by V minus U, this portion, divided by A, this one. So look at the previous one, U plus V into T by 2. So we are replacing the value of T, so we get this equation. Now look at this function, it's U plus V, let me write here U plus V into V minus U, right? Look at this, V minus U, V is the first term. Now this can be written like, the first function I'll write V plus U, this is V, so I'll just interchange this, V plus U into V minus U, right? And why did I do that? If you multiply these two functions, you will get V square minus U square. That means this particular function can be replaced by V square minus U square, right? So therefore, S equals, please remember, we have started with distance covered, right? And what is that distance covered? Area of the entire trapezium. So distance is given symbol small s. We already have studied this. So S is equal to V square minus U square by 2A. So now you cross multiply, you get 2AS. This 2A into S is equal to V square minus U square. And this is what the third equation of uniformly accelerated motion. Now when you are asked to prove this equation using a graph, let's say you are asked to derive third equation of uniformly accelerated motion, right? You need not write all these numbers here, just draw the graph. These values are not required, this just to be familiar with the graph, to understand better we have taken it. You can simply draw the graph, right? But you have to mention what is U, what is V, and what is T. Like, consider a body moving with initial velocity U and final velocity V with an acceleration A. So our U, V and A conditions are over. What is left is T. So let the time be T. So always remember, you have to first assume this. And next, very simple, we know that area below velocity time graph is distance covered, and then it's very smooth. You need to remember that you are going to replace a value of T here, and that will fetch you 3 or 4 marks, right? This is how you have to represent on your answer paper. This is the final output which should be there in your answer paper, right? Rest all things are not important. Thank you.